The context that I worked on with colleagues at the University of South Australia is based on some microbiology practicals. And so with this one, when you open the interface up, you get a little Bunsen burner, you get a picker, a swab, an oven, and some other paraphernalia that we'll talk about as we go through. Now, the guys in South Australia actually wrote this up. So having deployed it to the students, they got their findings published. So Layla, Connie, and Maurizio have done a great job at not only deploying a great context, but communicating it as well. Now, there are sort of two areas to this. The paper actually came from quite a simple deployment, and that was one where the students were looking at antibiotic sensitivity. So what they would do is they would create a lawn of bacteria. They had 3 bacteria to choose from, and that lawn of bacteria appear on a petri dish. Now it's a little bit bright, so we'll just turn the brightness down, and you can see if we lift the lid on this, there's some bugs or little colonies growing as a lawn on that plate. Now what they could do is generate some antibiotic. So many antibiotics were possible, but these antibiotics appear on a disc. Let's just choose ampicillin at a concentration of 50, and we create that disc, lift the lid, select the disc, and place it on the lawn. Let's close the lid again, and let's pop that in the 37°C incubator, so we can see that there's a little icon there that shows that it's in there. And if we start the stopwatch and wait 48 hours, no, I'm only joking. Let's dilate time a little so that we can actually speed things up. After say about 16 hours have passed, we'll take the speed back down to normal time, and we'll open up the oven, and what we see is that the colonies of the lawn has grown a little bit more, but the antibiotic has diffused out of that disc and created this zone of interference. Now, the really nice thing about what you're able to do with this system is that when you generate the petri dish, you've got any number of bacteria that you want. When you generate the antibiotic discs, you've got any antibiotic you can think of at any concentration. And so the number of permutations that you can get are absolutely huge. So great for setting assessments, great for getting students to plot the relationship between concentration and zone of interference size, getting them to plot the relationship between that and the amount of time that's in the oven. All sorts of interesting and creative investigations as to cause-effect relationship are possible with that system. Let's just delete that plate. Now the other little part of what we set up was the ability to generate a culture plate of cells. So in this case, we've got some E. coli growing as colonies on a suitable nutrient medium. And we can actually pick those colonies off and put them into some saline. So let's open up the lid and use our picker here to pick the colonies off. Now before we do that, we'll actually put the picker into the Bunsen flame, and then we'll have that picker nice and hot. Now we should let it cool down, of course, because otherwise we're going to burn our colonies, but let's pick some colonies. So we just touch the picker onto the colonies, it will pick them up, and then if we put those into the saline, then the colonies can get transferred into the saline. Now, if we just generate a nutrient plate, one of these Muller-Hinton plates, and then open that up, and this time use a swab, put the swab inside the saline, this solution where we've got the bacteria resuspended, we can start streaking those bacteria on the plate. And just to show you that that is a real thing, I'll actually do what nearly all the students will end up doing, and that's making some sort of amusing shape. So if we draw a big smiley face on here, then what we will find after we've done a few applications is that we can put the lid back on, put that back in the oven, and let's restart the stopwatch and turn time in a sort of Harry Potter-esque style. And then when we've put that for a little while, when we take it out, we should see that we've got a little bit of a smiley face. So we've got the colonies there. Now, of course, we could combine the colonies, this idea of picking colonies, spreading them on a plate, and applying the antibiotic discs as well. Um, we there's a lot of different things a student could do wrong in doing that sort of procedure. They could get contamination by not having a new swab. They could contaminate just by not using the Bunsen flame. So lots of opportunities there for us to build in mistakes, build in things that are going to cause variance at this stage, the temperature of the incubation, the time of the incubation, and so on. Now these solutions here, they are just sort of standard solutions. They're to be used in contrast with this little grid here that allows you to get some sort of visual feel for what the concentration of the suspension is. And again, that's something that the staff in the University of South Australia use to gauge how much bacteria have been resuspended. So lots of options there. But as I said, the principal one that led to this really interesting paper was the antibiotic sensitivity testing, which opens up lots of opportunities for plagiarism-free assessment because of the sheer number of combinations that can be given and recorded by the system. So some interesting motifs there. Hopefully we'll explore some of those ones with the plating a little bit further as our relationship continues.